Hello. Again, in this video, I'm going to do problem number 3 from the quiz, which is applying the fundamental theorem of calculus to take a derivative of an integral function. Okay, so I'll just write down the formula that is a result of fundamental theorem of calculus. The derivative with respect to x of an integral that has, let's say, the limits of integration are two functions, I don't know, let's say g of x and h of x, and we're taking the derivative of some function f of t dt, right? Remember, the derivative and the integral are inverse operators, so they kind of undo each other. In this case, it's a little bit more involved because you have to worry about the chain rule when you're taking the derivative. So in this case, we'll have f of h of x times the derivative of h minus f of g of x times the derivative of g. Okay, and so this becomes f of h of x. By the way, your f of t in this case is just cosine squared of t, right? So you're just going to put the whole, and your h of x is pi x squared, and your g of x is simply pi x, right? So h prime of x, you know, is 2 pi x, and g prime of x is simply just pi. So, so this then becomes, so I'll write it out, d dx of the integral from pi x to pi squared x, pi x squared, excuse me, of cosine squared t dt is going to be equal to f of h of x. So I'm going to just plug in pi x squared into the cosine squared function. So it's going to be cosine squared pi x squared times the derivative of h, which we said was 2 pi x, minus cosine squared of g of x, which in this case is pi x, times the derivative of g of x, which is just pi. Okay, so I guess we could clean it up. I usually put the 2 pi x out front. 2 pi x times cosine squared pi x squared minus pi times cosine squared pi x. Okay, so that's the answer I was looking for. It's just a direct application of this theorem. So let me know if you have any questions about this one. Thank you.